In this lesson, we're going to be finding distances between coordinates. Now, in this Cartesian plane, I've got two already plotted, -2, -3, and 4, 2. So from left to right, this is our point 1 and this is our point 2. Now, in order to find distance between them, which is this length here, and we're going to talk in units, not meters or anything like that. We're talking units here because we're talking units on this Cartesian plane, and you can see my 1 centimeter grid paper has 2 units there, so 2, 3, 4 there. Okay, so to find the measurement from here to here, or the distance, we have to actually think about what kind of triangle can we make out of this. So it sounds a bit silly, but we have to think Pythagoras, because if we go, all right, the distance between this x point and this x point is this much, and then the distance between this x point and this x point is this much, suddenly we have a right angle triangle. And we know from talking about Pythagoras, this side squared plus this side squared will give us the hypotenuse squared, or the side across from the right angle, which is what we are finding the distance. Okay, so we need to find the change, and that's that symbol for change in the x value, and then, just going to focus this, so finding the difference between the x values and the difference between the y values, and we're going to then square them in the same way that we would do Pythagoras. So remembering, if this is our Pythagoras, a squared plus b squared equals c squared. This is a, this is b, we're trying to find c here. So we are trying to find this value here. So our distance formula, to find distance squared, or our c value, then we would need to square the change in the x and add it to the change in the y value. So the change in the x is this side, the change in the y is this side. If we only want distance on its own, then we would square root this side to remove this square. So this is our distance formula, the square root of the change in x squared plus the change in y squared. Now the only way we can find out that change in y is if we say, all right, x2, or our second point, take away our x1 point, and that means we can find this distance. And the same for our y. Take our second point and take our first point away from it. So our distance formula is this. The square root of x2, take x1, so we can look at the difference, all squared, plus y2, take y1, all squared. So this is our formula that we're going to keep working with the whole time. Okay, so let's actually find the distance between these 2 points. We've got our first point, -2, -3. This is x1, y1, remembering this is an x point and this is a y point. And our second point is 4, 2. So this is our second point, so it'll be x2, y2. So let's do our formula first. D equals the square root of x2 take x1, all squared, plus y2 take y1, all squared. Okay? Slow and steady, every point at a time. So here's our long square root sign. Our x2 point is 4. So in it goes 4, take our x1 point of -2. See how I've got the take and the negative sign in there? We need to include them both. All right, our y2 point is 2. We are taking off our y1 point of -3 and squaring them. Okay, let's do the maths on this now. 4 take -2 is actually, the take and a negative becomes a plus. So we've got 6 squared here, plus 2 take -3 will turn into 5. If you would like to do that on your calculator, to make sure, do that. So now we have these values. We know that 6 squared is 36. We know that 5 squared is 25. We can add them together and we get 61. And if we get our calculator and do the square root of 61, we will find that the distance between these two will be 7.81 units. So the important thing to remember, number one, we do have to learn our distance formula. It is very important to understand how these points relate. The first point on the left, we read from left to right, is our point 1, which means its values will be x1, y1. The second point along from left to right will be our second point, a coordinate, therefore x2, y2, and we substitute into our formula.